Okay, so this is 8th grade, 6, 7, and we're talking about similar figures. And this is a specific, well, definition, and I wrote it down for you guys, and you copied it down already. Figures are similar, or they're considered similar, if you map one to the other by rotations, reflections, translations. Now they're adding dilation. You guys just learned about dilations. So if you have, two triangles and one's bigger than the other, you can dilate it to make it larger or smaller, and then you need to figure out if you can rotate it, translate it, or reflect it onto the other one. And if you can, and it's a perfect fit, then they are considered similar. So example 1 here. Let's see here. It says two-dimensional figures are similar. And again, there's that symbol that you'll be seeing if you map one figure to the other by a sequence of rotations, reflections, translations, or dilations. Hopefully you guys copied that down. So in example 1 here, we've got two figures, and it says determine whether there is a sequence of transformations, including a dilation. Obviously, you're going to have to make one smaller or one larger, and then see if you can map one on top of the other, and you can. And so if you, let's see, it looks like you're going to dilate one with a scale factor of 1/2, and then looks like you could reflect it. And so you could map one on top of the other. And then down below the triad, I did circle that. The question is triangle ABC, which is the smaller one right down here, similar to ABC prime, which is the larger one? And the triangles are blank similar. I'm not worried about the convince me. All right, example 2. Let's see here. It says quadrilateral JKLM. Looks like it's the black one. And then it gives the coordinates. And then it says graph JKLM double prime, which is the image of JKLM. So let's see here. The blue one is the one that's double prime. By a dilation with a center of 0, 0 and a scale factor of 3 and a reflection across the x-axis. Well, they go through the steps and they do that. Example 3. Identify similar figures. Again, I'll let you guys look at that example on your own. This is really a lot of what you already know, except that they throw in dilation to see if two figures are similar. So they try it down at the bottom. I do want you to do that. It says graph the image of JKL. That's this one. After a reflection across the X line. So, and that would be 1. Okay? So remember, this would be the x-axis. And it says across x is equal to 1. So if this is 2, 1 would be right here. Followed by a dilation with a scale factor of 1/2. So is it going to get larger or smaller? It's going to get smaller because the dilation is less than 1. And a center of dilation at point J. So you'll need to graph that. And then the question is JKL similar to PQR? And if yes, explain. $354. I had you guys copy this down. Number 1, how are similar figures related by a sequence of transformations? You can map one to the other by a series of transformations. Number 2, how do the angle measures and side lengths share in similar figures? Well, the angle measures don't change, but the side lengths are related to the ratio. So let's say there was a side length of A and B, and the side length was 3. And then there's a scale factor of 2. The new side length would be what? 2 times 3, that's 6. Okay? If it was a scale factor of 1/2, the side length from 3 would go from 3 to 1.5. Generalize. Does the given translation, reflection, or rotation followed by a given dilation always map one figure to the other? No. There's no guarantee that just because you do those different transformations that they're similar. Sometimes they're not. Okay, number 4. Is trapezoid ABCD similar to EFGH? Explain. Well, let's see here. ABC similar to FGEH. They gave us some side lengths. This one's 20. This side is 10. So what do you think the scale factor going from the larger to the smaller would be? It'd be 1/2. Does that work here? This is 28. This is 14. Yep. This is 32. What's happening to 32? 16. Okay, so that works. Now, notice the angle measures. When you dilate something, the angle measures don't change. And they didn't give us what the measures were, but they used just a single symbol here. And so you see that same single on those two. So that means their angles are the same. And here we have 2 and 2 and 2 and 2. So that stays the same. So the answer is obviously yes. And so explain how. Okay. Use the graph for 5 and 6. It says triangle ABC is dilated by a factor of 2 with the center of dilation at point C. So this is important. So when you dilate it, you're dilating it from point C right here, and a scale factor of 2. What's that?
What does it mean, dilate at point C?
So look at it this way. The scale factor is 2. Okay. And here's point C, and we want to dilate this length by 2. So right now, from C, it's 2 to the right and up 1. Well, I just need to double that. 2 to the right and up 1. So now we have B prime from this point. Okay. And A also, scale factor of 2. A is 1 to the left and up 1. Well, I'm going to go 1 more to the left and up 1. And this is A prime. And so now I could draw my new triangle. Okay. So ABC is dilated by a factor of 2, so we've done that with the center of dilation at point C. And then it says reflected across the x-axis and translated 3 units up. Graph the resulting figure. So I'll let you do the rest of that on your own.
Wait,
yeah.
Did you do the factor 2 for that shape?
I did. So we went from C, and it was B, and I just looked at it this way. B was 2 to the right and up 1, and so the scale factor was 2, so I just doubled it. 2 to the right and up 1. Just did it again.
Like,
Okay? And then, so graph that figure. And then 6, it says, is ABC similar to DEF? Explain. All right. 7. Do all of those. 8. Answer that. And if the answer is yes, explain it. 9 and 10. They're talking about PQR here. Is dilated by a scale factor of 2 with the center of dilation at 0, the origin, and then rotate at 80 degrees about the origin. Of course, they don't tell us which way, but it wouldn't matter. And then graph the resulting similar triangle X, Y, Z. Okay, do number 10 also. 11. Explain. If it's yes, scratch out 12. Not worried about that. Do 13 and 14. Okay, questions? Yeah. 7, 7, 7, 7. Yeah, 7, just circle all those. And I do want to say, tomorrow, assuming we have time, we're going to start angle lines and transversals. And that can be, well, I think you guys will enjoy it, but you'll have to pay attention. It can get kind of difficult. All right,